All right. So welcome back to another installment of our Hello World workshops for beginners. Last time we covered essential tools, so like downloading Visual Studio Code, Node.js, Git, maybe one other thing, to get all the tools you needed set up in order to move forward in our web development here. This week, we're going to be covering HTML, CSS, and JavaScript. And the reason you have that one there is it's probably going to be a couple of workshops of these languages because it's not something you're going to be able to just pick up in 2 hours here. They really are fundamental technologies, so they have a whole lot of different content we need to cover. So you can kind of see our outline of what I'm planning to go over today. How does the web actually work? So if you've ever wondered, like when you go to google.com, what happens? How does that work? We're going to go into at least some of the details of how that works. We're going to talk about living standards, and not living standards in the case like rising living standards for people across the world. We're trying to improve people's lives. Living standards in that these are standards that change over time. Then we're going to write your very first HTML file. We're going to talk about CSS, and we're going to write your very first JavaScript file as well. And we're finally going to go over the browser console and the developer tools that are included with your browser that you'll need if you want to be a good web developer. So if you have any questions throughout this presentation, feel free to put it in the chat. I'll be checking periodically. With that, let's go ahead and get started. All right, so these are some general notes just for throughout this presentation. Computer science in general uses a lot of complicated words or acronyms for what is usually actually pretty simple. So a lot of these ideas are relatively simple things, but they have fancy terminology. You also have a lot of words that are like people use them a lot, but what exactly they mean can mean different things depending on the context, or they're just not well defined. People might say something like, this language is weakly typed, but what that means to different people can mean different things. So that also kind of adds to the confusion. In addition, a lot of best practices and the popular frameworks in web development are changing constantly because we're just learning over time better and better ways to do things, and our needs, our expectations for the web increase. So 20 years ago, people didn't really expect to be able to watch 4K content through their browser. But today, people expect to be able to stream YouTube videos, Netflix, So as expectations increase, we need more powerful tools to do what we want. But as a result of this, you have a lot of older tutorials on the internet, especially for JavaScript, that use outdated ways of doing things or actually like no longer work. If you follow the tutorial, it probably doesn't even work anymore because things have changed so much. So the landscape is difficult to navigate, but if you stick with me here today, I'll try to teach you the basics so you can navigate through the kind of stuff you're going to see in like online tutorials and such. So the very first thing we want to talk about is how the web actually works. So when you go to, say, www.google.com, the way that works is you're connecting to a server. So google.com is just another computer somewhere else. And this is a simplified model. So if you're very familiar with how the web works, spare me the details that might be a little bit wrong here. But basically, you might have a client device. You can see in our picture here, you might have a phone or a desktop or a laptop. Those connect through the internet to a server. And a server is just basically you can think of it as like most of the time you have server racks, or it's like a desktop, but not connected to a monitor because no one's actually using it to like browse the web or do homework or whatnot. It's being used to serve up this web page. So this kind of forms a client-server architecture, and you see this as a standard thing throughout web development. You have clients that consume information and a server that has the information. It's the central server that stores the information and will give it out to people who ask for it. So that's kind of a pattern you're going to see repeated throughout web development. But that's how a website actually works. So if you go to google.com, at least in a simplified way, if you go to google.com or any other website, your computer is going over the internet and talking to another computer that's owned by that company. That's how it works. Or in most cases, for large websites, they have many, many, many computers. You also have this concept of the front end. So you might hear people talk about the front end and the back end a lot. And you're like, okay, well, what does that actually mean? The front end is all the code that runs on the client. So if you remember from our slide back here, right, the client is your device, what you're using to browse as like a user. So it's code that's running actually on your device. Usually in web development, this is controlling things like how the user interface looks. So what does the web page look like? How does it work on the client side? That's something else you hear. So people might call it the client side, the front end. They mean more or less the same thing. And this is primarily built with HTML, CSS, and JavaScript. Some languages have ways to also be on the web, but for the most part, these actually compile down into HTML, CSS, and JavaScript. So if you have other languages that you use on the web, at the core, those are the things that actually run. Because if you think about how your browser works, so your browser is kind of your client, right? Your browser is the one that actually talks to the server. So on your client, you can think within your client, your browser like Chrome, Firefox, Edge, Safari, whatever browser you use, they implement all the code that parses the HTML, parses the CSS, parses the JavaScript, and decides what to do. So that's why those are the three main languages you see on the front end. The back end is a little bit different because as long as it serves up the right response to the front end or back to the client, it can be written in basically any programming language. So on the front end, you basically see HTML, CSS, and JavaScript. On the back end, there's lots of different languages people use. So people use Java, you can use Python. If you really like JavaScript, something that has grown in popularity a lot is Node.js, which I actually had you install before, is just another way to run JavaScript, but on your server. So originally JavaScript ran primarily on your client, but people decided they liked it so much, they wanted to run it on the server as well. So they mentioned Node.js, and so that's a way to run JavaScript on the server. But most popular programming languages you've heard of probably will run on the back end. You hear people talk about this as server side. So usually you either hear front end, back end, or client side, server side. Those terms they mean the same thing. And you don't necessarily need an extensive backend for a lot of applications. So if you just have a static site, like if you have a website for just a personal website, maybe kind of like a resume site where you store your projects, some data about yourself, contact information, like a professional sort of website. You don't necessarily need to be doing anything like fancy. All you want to do is serve up a page that never really changes or changes infrequently. In that case, you're going to have a very simple backend because you don't have to like store. If someone visits the page and then they come back a week later, you want to give them back the same page, right? Nothing is changing. So you don't really need an extensive backend. Most of your work will be on the front end. Whereas if you have something that does change, like say something like Google Drive, it's heavily server driven. It has a very extensive backend because people are uploading files to it, changing things on that, and they expect to be able to see those changes propagate. So that's where the backend usually ends up being more complicated for more complicated applications. In terms of languages, so let's talk HTML. So HTML stands for Hypertext Markup Language, and it describes your structure and content of your web page. So this presentation is written in HTML because I've been trying to become more and more proficient. So I've been starting to write my presentations in HTML. But it's just a way that you can write the content of your page. So all the text that's on your page, that's where you decide what images you want. All the actual content is going to be written in HTML. If you actually read HTML code, and we will get to that later in this workshop, you can kind of think of it as like a tree diagram. It's not very pretty to look at the code, but it describes what the overall structure of your website is going to look like. It's useful for static content. So like this presentation, right? It's not like actively changing while we use it. If I go back a slide or go back to this presentation later, it's still going to be the same, right? You don't have things changing. If you do want to have a page that is more like an application, so something like a Google Drive or Google Docs, right? Where as you put in user input and you add input, things are actually changing and the page interacts with you. That's when you need JavaScript. So JavaScript is all for your interactivity. HTML is good for static content, things that don't really change. You also have CSS. So we talked about HTML. CSS is a way to manage your presentation. So this is all of your formatting stuff. So if you love design, CSS is where you want to go. You can do animations with it. It actually grew. Originally, there wasn't CSS. So when the web was first invented, you just had HTML. And they tried to add all of this formatting stuff into HTML. But as they did it just became more and more complicated and got to the point where they felt like they should break it off into its own sort of thing. So they did that and they called it CSS. And so HTML and CSS are very closely tied together. Like you don't really use CSS on its own or HTML on its own. If you're using one, you're guaranteed to be using the other. And you're probably going to be using JavaScript as well. Although if you are having like a static site, you can get away with just HTML and CSS. But it's all about how it looks, the presentation. Functionally, it doesn't usually do a whole lot in terms of like making your application do new things, but it can make it look very pretty while it's doing those things. And then you have JavaScript, which is probably that's the big one here. A lot of people think it's the same as Java, and it makes sense that they do because they're both named very similarly. It's actually a pretty funny story why it's named JavaScript. The people who invented JavaScript, at the time, Java was like being super hyped up. Java was one of the most hyped programming languages ever when it came out. They put so much money, like millions and millions of dollars into the marketing campaign for Java. And the people who had JavaScript were like, look, Java is hyped so much. People think it's like the next big thing. So we need, in order to make our language popular, let's just call it JavaScript. So it's kind of the same. People will be confused and think it's sort of similar, or they might be more encouraged to use it. So that's actually why it's like that. It's like almost intended to be confusing like that, but they are not the same. They do share some features, but they are definitely very different languages. You can't really run Java on the web these days. If you remember back when we had Java applets, so you would like load up a page and there'd be a box and it would be like, do you have Java? You used to be able to run Java on top of in your web browser, but it had like terrible security problems and JavaScript just became more popular. And at this point, there aren't very many pages left that still use like Java applets and that kind of stuff. Flash was another competitor in that thing. So if you remember Adobe Flash, that was another thing that was like kind of a competitor to JavaScript, but all of those died out and JavaScript is now the dominant thing. Yeah, what's interesting about this, I see people in the chat saying they remember this stuff happening. The web has really significantly developed like during our lifetimes. Like if you remember when you were a kid and like Internet Explorer was like the only browser, right? Things have changed significantly. And JavaScript at that time was just in its infancy. So yeah, I always find that really interesting. Like I kind of grew up with these web technologies developing. So yeah, basically it started out as a way to kind of hack on some interactivity because people had HTML and they had CSS and they're making sites. And they're like, well, it would be nice if I could have like a button for people to click. Or you remember when they had those trails on your mouse? When you like move your mouse around, there'd be a trail of stars or whatever. All those like meme things that they did. That was the original use case for JavaScript. It was kind of almost an extension of the HTML CSS thing. Like they were like, okay, we want to do some things that are a little bit too hard to do with HTML and CSS. So we'll add JavaScript. It wasn't really meant to be like a full programming language, just a thing that designers would use to kind of augment their HTML and CSS. But what happened is people started using it for like bigger and bigger parts of their application. Some major applications got written in JavaScript, which it wasn't really meant for, but it was able to do. And they just kept adding new features to JavaScript until it became better than everything else, better than your Java applets and Adobe Flash. And so now it's completely taken over. And it's continued over the last like decade to continue to dominate in other ways as well. So it started out just with your front end, right? Just your client side, just for helping you display your page. But now it also runs in the back end, like I said before, with Node.js. And if you use frameworks like React Native, you can actually run it on mobile as well. Or if you use Electron, you can build desktop apps with JavaScript too. So like if there's one language you want to learn, in my opinion, it should be JavaScript. Because if you write something in JavaScript, you can run it basically on any computer that we have, which is you can't say for a lot of programming languages. It's one thing about it though is it's one of the fastest changing languages. So that's something I brought up before with the tutorials. In the last 10, 20 years, it has changed so much what the best practices are and just the language features. It's added so many new things that keeping up with it, like even on a yearly or every 2-year basis, what you know will be out of date. New things will have been added. So it's important to make sure that you're reading, if you are going to like read tutorials or watch videos, that you're watching things that are created more recently and are up to date, because otherwise you might be learning, the old wrong way to do it as opposed to the current correct way. It's also called ECMAScript because there was a whole like legal thing, and there's a bunch of reasons, but ultimately the official name ended up being ECMAScript, which people joke sounds kind of like a skin disease, and I agree. But in practice, most people call it JavaScript, or JS for short. And what's really great about these languages is they're all text. So you don't have to learn like any fancy application to be able to edit these. You don't need to like download Adobe Photoshop or something to be able to use and learn this crazy interface to be able to use these. They're all just text files, right? So an HTML file is just text with .html, and CSS is just text with .css, and JavaScript is just text with .js. So if you can type, then you can write code in these languages. All right, now I want to talk about living standards. So not all of these languages were originally living standards, but now they all are. What that means is that they change gradually over time. So all of these different languages have a committee that's actually dedicated to like maintaining and improving the language. And people who are members of the committee can say, hey, here's a cool feature from, maybe Python or something that I like. I think it should be part of JavaScript. So they write up a proposal on, okay, here's what I would like to do. I'd like to add this feature to JavaScript. And then the committee talks about it. They talk about it. And eventually they vote on it. And if it ends up passing, then it is set to be implemented. One thing that's important to note is people have to actually implement these changes. So once the committee says, okay, we've decided to add this feature, it doesn't automatically mean that it will start working, right? Someone has to, if you think about your browser is an extremely complex C++ program that knows how to take HTML and turn it into the graphics on your screen, knows how to take CSS rules and adapt your HTML to show up like that, and knows how to take JavaScript and run that code. So it's all written in C++, or recently some parts of Firefox have been written in Rust, but C++ is the main one. Modern browsers, the people who write modern browsers are not given enough credit these days, I think. A lot of people just download the latest release of Chrome or whatever browser and they think, okay, this is great, it runs pretty well. Or I even hear people complaining like, oh, my browser's too slow, it doesn't do these things. But the lengths these people go to make your browser faster, to implement these new features, especially as you start to become like a more competent web developer, the kinds of things you're able to do with just like one line of CSS or one line of JavaScript, and then you try to imagine whoever actually wrote the code that makes your code run, it's absolutely insane. I mean, I would even say, if you wanted to write a modern browser from scratch today, it's probably comparable to the effort of launching a rocket. Like if you think, I kind of looked at the timelines, how long it took Elon Musk to start up SpaceX. It was started in like 2004, I want to say, something like that. And Chrome was started around the same time. So if you want to do it from scratch, it's probably equivalent or harder to do than launching a rocket. So these browsers are insanely complicated, insanely impressive. I want to give lots of props to people who write browsers. When you write a browser, you have to go and read through the standard and implement it. So your living standard is whatever the most like up-to-date version of HTML, CSS, and JavaScript are. And remember, these are changing all the time. So the people who work on browsers are constantly having to see, okay, what does the committee change this time? And go and try to implement that into the code base they already have. And this is pretty difficult to do because the committee likes to add, like the committee might say, okay, we want this to happen, but it might be extremely hard to actually make that happen. So no browser actually fully implements the complete standards of all of those. languages, but for the most part, they have all of the features that you're going to be using on a daily basis. Some of the newer things, especially these days, browser standards have gotten a lot better. People follow them. Back when we had when Internet Explorer 5 and Internet Explorer 6 were like the main browser and they had like 90% market share. Internet Explorer kind of just ignored the standards and did their own thing, which was terrible for web developers because they had to write different JavaScript code, for example, different HTML, CSS, and JavaScript to work on Internet Explorer, because Internet Explorer might do some things like the standard, but other things worked slightly differently or just didn't work in Internet Explorer, or Internet Explorer had its own thing you could do that didn't work in any other browser. So that's why it's important that we have standards that everyone follows. That way you don't have to write one version of your page for Chrome, one version of your page for Safari, one version of your page for Firefox. People used to actually have to do that kind of thing, and it was truly awful. So it's important that we have standards that browser vendors can follow. And that's what we call that our living standard, or our specification, or for very short, the spec. All right, so that's kind of a high level overview of how the web actually works, right? So if we go all the way back, it all starts with your client server architecture, right? So on your client, you have a browser. Your browser knows how to talk to your server. The server takes information, sends it back to the client, and your browser interprets your HTML, CSS, and JavaScript and is able to display the page, working hopefully pretty well for you. So with that, I'm going to go ahead. Let's actually write some code. So I actually wrote up a sort of a template repository here on GitHub. So you want to go ahead and pull up VS Code at this point. So if you don't have that installed and you're just watching, that's totally fine. But if you do, go ahead and pull up VS Code, and you're going to want to pull up GitHub as well and fork this repository. So I'll give people a minute to do that. Forking, by the way, on GitHub is just a way to make a copy of a repository that's like your own personal one. So if you head to this URL, which I don't know if you can see it very well, I'll put it in the chat. Yes, I'll send the link. Okay, so if you head to that link, that will take you to this repository. Yes, so you can use any editor. I'm actually going to be using Vim today because I had you all install VS Code, but I don't actually daily drive it. So I'm usually running Linux, and I write most of my code in Vim. So any editor is fine. As long as you have access to a terminal with Unix-like commands and an editor that you know how to use, then you should be fine. So what you want to do is head to that URL. So once you're here on this URL, you'll need to sign in. So go ahead and do that. And then you'll see this button here that says fork. When you press that, it might ask you some questions, but it should make another copy of the repository on your own GitHub account. So I'll wait a minute or two for people to do that. Let me know when you get that done. Are there any questions, by the way, on any of this stuff? I know I kind of went through that slideshow pretty quickly.
How do I fork?
Sorry, what?
How do I fork?
How do you fork? Okay, so do you have a GitHub account?
I'm open to your repository. I'm just trying to figure out what to do from here.
Oh, okay. So right over here, you see where it says this fork button? You just click it.
Oh, it's on the right. I'm blocking it with my Zoom.
Okay. You're fine. You're fine. So yeah, you click that. It should take a minute, and then it will take you to a page that looks a lot like this. But instead of saying Rob3, right, that's my GitHub username, it'll say your GitHub username.
Gotcha.
If you're still working on that, that's fine, but I'm going to go ahead and move ahead for people who have gotten the fork to work. The next thing you're going to want to do is head to this green code button. So right here, this is the button this is like the button I use the most on GitHub. This is how you actually get this code from GitHub, which is a client, is a server. So actually GitHub you can think of it as a client server as well, right? So GitHub is a server, and your device that you want to get your code on is your client. So to download your code from the server to the client, you're going to need to use this link here. So you go here, grab this HTTPS link, copy it. And then if you head to your terminal and type git clone and then that link, It should be pretty quick because it's just text files, so there's not a whole lot going on. You should get something like that happening. Are people able to get that working? Yes, no, maybe so. Okay, people are getting it. Okay, great. If you are still trying to get that done, like please interrupt and I can hold up for a minute.
Like I missed the last meet we had. Do I need to get like the Git? What's it called?
Yes, you'll need Git. If you weren't at the first workshop, so the original workshop in this series, Essential Tools, has like it gives all the instructions for downloading and installing. But if you want to try to like catch up, if you just had to, I think it's git-scm.
I need like the bash, right?
Yeah. Okay. So git-scm.com. And head here, and you should be able to grab whatever operating system you're on. You can grab a download for that and get that installed. Okay, so once you have that, you're going to do git clone. We're going to head to this code button, copy this thing here. This is something that probably a lot of workshop hosts will like. They might give you, if they give you a GitHub link, this is how you like actually get the code. So if you're always wondering like, okay, I see that Git link, but like, what do I do to like actually download it? This is what you do. You go here, you go to the whatever the page is. You can, if you want to be able to make changes to it, you can fork. If you just want to read the code or not be able to push up new changes, you don't need to fork it necessarily. But I usually would just go ahead and fork. You can always delete it later if you don't want to keep it. Take this, go back to your terminal, and then git clone with that URL. And it should create a new folder. So let's check. If you remember from last week, our bash command ls, right, that lists all the folders. You can see I have a lot of folders. But in this case, if you didn't put any extra folder name here, it should just be html-css.js template. So if you can see right there, we have that. So I'm going to go ahead and change it into that. Let me actually make this a little bigger so you can make sure you can read it. Okay, so remember cd change directory. That will help you change into the folder that we just downloaded from GitHub. And if you look in there, there are a couple of different files. So we have license MD. If you don't know what a software license is, please come to my workshop on Thursday where we're talking about software licensing. You can read it if you want. It's a permissive license. So you can do what you want with this code. I don't care. Then you have three other files. You have index.html, script.js, and styles.css. Usually you have some flexibility in what you call these files, but those are kind of like standard names that people use a lot. So first we're going to go ahead and take a look into index.html. If you are running on like Visual Studio Code, if you head up to File and then there should be an option like Add Workspace Folder or something like that. And then you choose this folder. So you want to navigate to wherever you cloned HTML, CSS, JS template. Then it should add it to your like little VS Code side tree. I don't really use VS Code regularly, so I'm not going to do that. But if you are using VS Code, that's the next thing you want to do. Anytime you clone something, that's something you want to do in VS Code to add it to your side tree. There's a question in the chat. Are we going to be doing anything with React or Node? Eventually, hopefully, yes, but definitely not today. We're just going to mainly hit on HTML and then kind of a very, very, very brief intro to JavaScript and CSS. I'm hoping to go into more detail on JavaScript during the next meeting. But depending on time, I don't know. I think we're doing pretty well on time, so I might have some time to go in that today. We'll see. So go ahead and you want to click into or edit index.html. Vim is just an editor that works on the command line. So you don't need to type Vim unless you want to try to use Vim. I encourage you to try it, but you probably won't like it. All right, so go ahead and edit the file. So you can see if we head up to the top here, you should see something like this. Are people able to get to the point where they can see this? Yep. Okay, we have one person able to get it.
I'm still having trouble.
You're still having trouble. Where are you stuck?
I've got the console opened up. I'm trying to figure out how to like clone the
Oh, okay. You'll have to install Git. If you don't have Git installed, it might be better if you just come back and rewatch this.
I have Git installed.
Oh, you have Git installed. Okay, then just run git clone and then that URL you grab from the green button.
Okay.
And that should download it. Okay, so you're able to get to this point. So you notice some things about, this is kind of a boilerplate HTML document. If you're not sure what boilerplate means, that's basically just code that you're going to have to include, but doesn't really do a whole lot. Like every project you need, every HTML file you have, you need to put this less than exclamation point doc type HTML greater than thing at the top. It doesn't really serve any, it does serve a purpose, but it's not really important for whatever your specific project is. It's just boilerplate. You have to include it. So if you want to use this repository as like a template for future, if you're trying to make an HTML page or something, by all means, feel free to do that. Some other things you're going to need. So HTML is made up of what's called tags. So a tag starts, usually tags have a start and a beginning. A good example would be this head here. So your start tag, you have this less than, and then you have whatever the name of the tag is you're using, and then this greater than. So that's your start tag. And then your end tag is the exact same, but you have this / before the thing. So you might notice like some other things like script here has the same pattern, right? You have script. You also have this other thing, which we'll talk about in a minute. But you have that, and then you have their closing script tag here. So our very first tag we actually need here is this HTML tag. That includes all the HTML in your document. So everything should go inside this HTML tag. It's just kind of boilerplate. You're going to need it. We also have this lang equals en. That just sets the language to English. If you don't do it, it will probably default to English anyway, but you might get a warning in your browser, which is why you should do it. And if we go all the way down to the bottom of the file, you will see there's a closed HTML tag. Okay, makes sense? Next we've got our head tag. So every HTML file is going to have this HTML tag and then two main subtags. So you can put tags inside of other tags. That nesting is what lets you make these complex structures and organizations of your page within HTML. That's part of why it's so successful. So you have inside your HTML, because right, this is all HTML, so it's all going inside of that tag. You have your head tag. This is like it stands for header. Usually this just contains metadata. So metadata is just data about your data. It's not stuff that the user is going to look at. So they're not going to actually see any of this stuff happen. It's more instructions to your browser mainly. So this meta char set equals UTF-8. That's setting the character encoding to make sure that it uses. So like if you were typing like lots of Chinese characters or something and you needed a different character encoding, you might put something else here. But in practice, I've never used anything but UTF-8. Again, it's just another boilerplate. If you don't put it, it will probably still work because the browser people who I was talking about before who work so hard, they work so hard that, even if your HTML isn't quite up to the specification, if you're not following the rules you're supposed to follow, they will do their best to make sure it sort of works as well as they can make it work. So if you don't include this, it probably will still work. You just might get a warning. And actually, I knew a guy who actually never put this in his code, and it usually never caused him problems. But I remember debugging one specific application that had a specific font rendering issue because he failed to put that line in his code. So that's why I recommend like using a template like this or looking it up whenever you make a file to make sure you actually are following the specification. Because although usually bad things won't happen if you don't, it's just good practice to do it. Sometimes bad things could happen. So that is something that is required. You also need this title tag. So we're about to open this file up actually in our browser. So this is a web page, believe it or not. This is what a web page looks like. This is a very simple web page. But this is what a web page looks like, and you will see where that title shows up. But basically, this will be the title of your tab. So whatever your tab says, so like if you went to Google, it might say Google, right? So in this case, this tab is going to say my title, and we'll see that in a minute here. This link here is adding in our CSS. So to add a CSS file, you just have to do this very specific pattern here. And this script is doing a similar thing for JavaScript. One thing I would say to note here is you can kind of see how this is sort of interesting, how the web has developed piecemeal because of the different styles they use. So if you notice, some tags like the meta tag or the link tag don't need to be closed, whereas other tags like script do, even though you never want to actually put things inside of a script tag. So yeah, is that the best way to do it? No. Like they could have done this better, but they just didn't think of it when they were making it. So too bad, is what we're stuck with. That's the main things you're going to see in the head tag. There are other elements you can put in there, but those are like the sort of 4 primary ones. You need to have this meta charset thing. You need to have a title. And then if you want, you can include CSS and JavaScript, and most pages will. The body is the most interesting thing here. So the body is like all the main content you have for your page. So right now, the only content that actually is displaying is this hello world from HTML. It's inside of a set of P tags. So P stands for paragraph. If you just want to have like a paragraph of text, you put it all inside of a P. All of this stuff in here that's kind of grayed out, this is all commented out. So in HTML, your comment looks like here. Let me actually, my editor redraws it, but basically it's a tag that starts with, you have this exclamation point dash dash. So you have your less than exclamation point dash dash, and that is like your start comments. And so all of this code has no effect. The browser doesn't read any of this. And then down here, you have dash dash greater than, and that indicates the end of the comments. So I'm going to like uncomment this as we go. But even if you deleted all of this, it would have no actual impact on this web page as it currently stands. So really, you can kind of think this is our very, very basic page. Those are just elements we're going to go over. So let's actually go ahead and open this page, and we can see what this looks like. So you're going to want to go ahead and open up your browser. Whatever browser you use is fine. And then open a new tab. And if you type either Control-O or Command-O if you're on Mac OS, and then you're going to want to navigate to that folder. So in my case, I put it inside this Nighthacks folder and inside HTML, CSS, JS template. And then you want to open up index.html. That should load the web page. This is essentially how your browser actually works when you go to a web page. So when you go to a web page and I say it sends back the data, right? You're basically requesting this HTML file. So it says, hey, I want to go to this web page. Give me the HTML for that page. And it literally downloads a file to your computer and opens it. That's all your browser does. We have a question. Could you do that one more time? Yeah. So you just want to open a new tab, Control-O or Command-O if you're on Mac, and then navigate to your folder where you have all these files, and you just want to open index.html. This is essentially how your browser works. It's just downloading your HTML file, and then it opens it. So yeah, you can actually kind of see we're actually at an address here. We're at file, whatever, but usually this would be a remote address, like not on your local machine, it'd be somewhere else. We have, okay, random question. Does the Wayback Machine just take a copy of the HTML files? If you're, yes. So I am familiar with Wayback Machine. For people who aren't, the Wayback Machine is, it's a web archiver. So what it does is like, maybe people are making edits to like Wikipedia over time, and you kind of want to see like, what did Wikipedia look like in 2000 or something? You can use the Wayback Machine to look back at that. And yes, this is exactly how the Wayback Machine works. It just downloads this HTML file and any other files that are related to it, and then stores it. And then it also like notes what time it did this. This is exactly how the Wayback Machine works. So good question. Yeah, that's what I was trying to say before with like, it's all text. Like there's no magic going on here. It's literally just downloading the HTML file, downloading the CSS file, downloading the JS file, which are all just text files. And then your browser is really where the hard work gets done. It takes the text and turns it into like an actual page, which again, browser implementers, like brilliant, brilliant people. So you can see right now, this is kind of a boring page, but it kind of gets across some basic things. So we have, if you notice, it says my title up here is the tab title. If we go back to the code, so that's what this title does. So if we change this to something else, like, I don't know, hello, right? Save that, head back to our browser, and then you'll need to refresh in order for it to like recognize changes have been made. No, it still says my title. Oh, that may be because I'm in the wrong one. Because I think I had this download from before. Yeah. Hold on. If I go to the correct one, it will change it. There we go. Okay. So it says hello. So that's how if you ever wondered how the tab title gets set. So like GitHub here has conveniently set that title attribute to GitHub-rob3 HTML. That's how it does it. It uses that attribute. Down here, so the body is what's getting actually displayed. So notice none of this other stuff has any impact on, you don't see any of that showing up, right? It's mainly just rendering what's inside the body here. So we have a paragraph and we have hello world from HTML. You might notice that it's red. That's because of our CSS. So remember how I told you CSS does formatting? So our HTML is just the content, right? The color isn't really part of the content per se, right? It doesn't express color or like anything like that, formatting. It's all about just what the pure content is. So the pure content is just the text. The color or how the font, all of that stuff is controlled by CSS. So if we actually open up our CSS file, so if you go to your editor and you open up your CSS file, you can see this is my very simple 3-line CSS. This is what sets it to red. We're going to go into a lot more detail on how the CSS actually works and how to use that in a future workshop. This is we're mainly going to be focusing on HTML today. But basically how this works is you see this P here. That indicates that the attributes inside of these braces are going to be applied to all of the paragraph elements, right? So that P is coming from this P over here. So if we remove this and instead just put the text instead of wrapping it in paragraph and then reload, look, no longer red. So it only does it for things that are inside the P tag. So if we do that, then you get some of it red, some of it not. Okay. So that's how that's kind of your basic CSS for today. Let's kind of explore some of the other tags that are available in HTML. So if you didn't delete all of that stuff, we can go back. I'm going to kind of move the comment down a line to uncomment some new code each time. So you have image, the img tag. If you want to display an image, this is how you do it. Use the image tag. It is one of the weird ones that doesn't have to be closed. You only open it. Again, there's no good reason why some of them are like this and some of them aren't. It's just, you have to think about how HTML and CSS were designed, right? They're designed over many years, over time, with hundreds of different people involved, all trying to get their feature in. So people didn't always necessarily talk to each other about the overall grand design. They just kind of thought, this is what I want. I think this would be cool. And so that's why you kind of had these conflicting sort of standards within HTML and CSS and JavaScript as well. So what you need to do for image, you need to tell it what image you want to use. So the way you do this is with the src attribute. So we kind of saw attributes earlier up here with some of our other tags. So this lang, right? And this char set, you can kind of see, basically, you can have these attributes where you type the name of the attribute equals, and then usually a string that is whatever the value of the attribute is. So in this case, src stands for source, like the source of something, source and destination. Like where are we getting this image from? So we can just go and grab, like Google a random image and put the link to it inside here. So let's see what like night hack stuff we can find. So Google that. Okay, this looks great. All right, so say I want to include this icon into my web page. I could host this on my own server. In this case, I'm just going to steal the one. Looks like this one's coming from GitHub, actually. If you just go to here and you copy the image location, and then you paste that into, it might be the other one. I always get confused which one it is. It might be copy link location. I don't know. Let's try both and see. One of them is actually going to give you the direct link to the image itself. The other one is going to be like a link to the page where the image is. Okay, looks like that was the right one. So it was the second one. It was copy link location. So if you grab that, that will give you a link to the image. And then if you put that as the source, reload your page, you're going to see that image displayed in your web page. So great. Okay, we have an image. You can point that source to like any image hosted anywhere. The only thing you have to be worried about is if that image ever no longer becomes available at that address, then this will stop working. So, you know, if GitHub decides to take it down, then this link will stop working. This is like usually a good reason why you want to host any images you use on your own site. That way, you know, you'll know if your own site goes down, you know, if you remove an image, then you can expect it to disappear. Whereas you have no clue what other people might do. But you can use other people's images. Just make sure you follow all the relevant copyright laws. So like, don't just, I'm sure Nighthacks doesn't care if I do this, but like, don't steal random images from like, you know, a photographer's site or whatever, unless you actually have permission to do that. That's the image tag. There are some other things about it that you can learn, but that's like the most basic form. Next thing is the A tag. I'm not sure why it's called A because it's actually just a link. We have a question. You clicked on copy link address, right? I think that's the one. In Chrome, it might be different too. They might call it something else. I believe it's copy link location, or yeah, in Chrome it might be copy link address. But if you're not sure, I always just end up trying both because I can never remember which one it is. If you actually are like making your own site with your own images you have locally, then you don't need to like worry about all this stuff. But if you're trying to just use random images from the web, then yeah, that can be a problem. All right, so our A tag is, I'm not really sure why it's called this, but it's how you make a link to something. So let's say we want to add a link to nighthacks.org. So what you do is you add a property that's href, which stands for hypertext reference. Because remember, HTML is your hypertext markup language. So they just called it hypertext, I guess, because they thought it sounded cool or something. I'm not really sure. But href stands for hypertext reference. And that is pointing to where you want your link to actually go. So let's say I want to go to Nighthacks. So, right, so I put that, that's my link. And then what goes inside the tag here, because if we actually do this, I'll show you, this won't actually do anything. We reload this page and you're like, okay, well, I didn't see anything happen. That's because the properties aren't necessarily getting directly displayed. They're kind of like metadata. They're data about what to do, not necessarily what to show. What goes inside this tag here is what shows. And although you commonly see people put a link that has the same content, you don't have to necessarily do that. So I'll show you what that looks like here. So we could just put that link there and that'll work kind of like how a normal link works. But you could also put like, you can put whatever text you want in here and it will still link to that same site. So look, now we have our two links. So this is kind of your standard link. If we click that, here we go, Nighthacks, great. Whereas this one, if you look, it's just Nighthacks, right? It doesn't have the whole address, but if you hover over it, you can kind of see, you see in the bottom left, it's kind of small. But if you see in the bottom left, it shows where I'm about to go. Chrome does a similar thing. And it still links to Nighthacks. So you can put whatever text you want there. You probably have seen people do this before, but that's how it actually works. So the href is actually the link you want to go to. Inside of the tags, you include specifically what text you want to be displayed, which could be the link. That's the least confusing way to do it. But if you want to be like, what people sometimes do to be like nefarious is you can put something else here. And then it will look like, they're like, oh, it goes to Google, but it actually doesn't, right? It doesn't matter what this text actually is. All that matters is what you put in the href. So that's that. That's how you make a link. All right, these next several are all formatting sort of things. So they're formatting in the sense that usually they're used to do formatting. And I know I said formatting was all part of CSS. And it is, but there are sometimes you need to emphasize certain kinds of things. So say you want to emphasize, you want to say something in like a strong tone, right? You want to indicate it should be said strongly. Usually this is indicated by bold, but if you put it inside strong tags, then it will put it, basically it will put it in bold, but you're not supposed to think of it as using it as a formatting tool. And I'll kind of explain that some more after we see how these work and why that's the case, because there are actually other elements that do different things. So if we put something inside here, I don't know. I'm not very creative, so I just put hello and everything. But yeah, well, let's put hello world in this one too. I'll be more creative on the next one. So if we put that inside of there, you can see that makes it bold. It doesn't necessarily have to make it bold, but that is like the standard way to make something bold. EM stands for emphasis. That's how you do italics. So do EM, you can see that makes italics. If you want both, you can do that. You just need to put it inside of both. Yay, it's both. Okay. Pretty simple concept there. Could you do M then strong? Yeah, it doesn't matter what order you do it. So we can switch it around. It should still do the same thing. Yeah, same thing. What you can't do, make sure that you match your tags up though. Like if you do this, I'm not sure this will work. This probably will still work, but this is like not in the specification. So you're not supposed to overlap. This might actually work. I don't know. It probably will work because usually they fall back. They do a good job falling back on things. But I don't know how well it will work if you put like other text here. I guess we can try it and see. Oh, it does work. Okay, never mind. Usually it's a bad idea to do this sort of thing though, where you like start things and then end them in like a non-nested way. Usually you want to try to nest your things, but I guess it does work for in this case. So that's that. You actually also have, so you have people, you might see in older code, people use the B and the I tag. These stands for bold and italic. And you might think, oh, well, that's shorter. Why don't I just use that? And the answer is, it does the same thing in all browsers. Oh, how can you move to a new line? Yeah, that'd probably be a good thing to do. Yeah, let me actually do that before. So I put it all the way to here at the end. If you take this BR tag, that's how you move to a new line. So let's put it like here, say. And then we might have to do like a couple more of these. So
you need to open and close, or just do you need to open and close that one, or is it just?
No, it's another one of those like self-closing ones, just like image or meta. Again, why is it like that? There's not like good reasons. That's just how it is. So BR stands for break. That gives you a line break. Yeah, there you go. That's how you can like break to a new line. Some elements like image by default will just automatically break to a new line like this. Other ones don't. Again, there aren't like particular reasons behind a lot of these things. It's just how it is. Okay, so yeah, that's that. You can just use a BR anywhere. You don't have to close it. That makes a new line. So you also have the bold and italic tag, B and I. However, these are, it's discouraged that you use this generally for bold and italics. And the best argument I've heard about this, for the most part, it will work fine if you do this. You might be thinking it's shorter, right? Why wouldn't I do it this way? It comes down to like a really semantic argument. And you might kind of like listen to this and be like, okay, I don't really care about that, but there are actually good reasons why it matters. But the argument is that, remember how we were talking about CSS is supposed to be about the presentation of your code versus HTML is just about the structure of your code. So if you say you want something bolded or in italics, you're talking about the presentation, right? You're saying how you want it to look, which is not supposed to be something you do in HTML. If you say something should be strong or emphasized though, that's something about the content, right? Like maybe you're writing like a paragraph about a speech and you want to emphasize something that someone says. You're not saying it should specifically be put in italics. You're just saying it should be emphasized somehow. Now, every browser does it by doing italics, but technically, that's not what it means. It just means the emphasis needs to be put on it. You might be thinking, okay, this is pointless. Like it's basically the same thing. But one area this does come up is accessibility. So there are people who write screen readers for HTML. So if you're blind, for example, and you want to visit a web page, if you have a screen reader, it can parse the HTML and it will read it differently depending on how you do it. So for bold and italics, it's just going to read that normally. But if you put strong, then it will read it in a stronger voice, or emphasis, it will read it with emphasis. So that's one important reason you should use strong and M over B and I, basically whenever. The only reason you want to use B and I is if you don't actually mean for something to be strong or emphasized. So maybe if it purely is like a formatting concern, like maybe you have a list of numbers and you want all of the numbers to be bolded. You're not trying to say that you should announce like 1 and really loudly and then say the rest of the thing after the 1. You literally are just trying to bold it. If you're trying to do that, then B is the preferred way to do it. So some people think they're deprecated, like you're not supposed to use B and I anymore. No, there are uses, but most of the time what you actually mean is strong and M. It is kind of a semantic difference. At the end of the day, it doesn't matter that much, but there are people who are blind who like to use screen readers, and there are accessibility reasons why you should do it that way. So it is important to do it that way if you remember and are able to. Does that confuse anyone? Does that make sense? I know that's kind of a very specific thing. And it is kind of a sketchy sort of argument. Like, why wouldn't you just make all the B and I work exactly the same on the screen reader and things like that? But that's HTML for you. Lots of things change, sometimes not necessarily for the best reasons. So prefer strong and M most of the time. The next thing you have is all of these H's. They stand for heading. So heading 1 is your biggest heading. Heading 2 is like a not quite as big heading. And then heading 3, it just keeps going down in size. So I'm going to do all of them so you can kind of see what that looks like. So there you go. You can see different size of headings. CSS can change how these look. So this is kind of, again, all this is the default, but it can all be changed in CSS. So if you want your, one heading to have like be in a certain font and a different heading to be in a different font, then you can do all of that in CSS. But by default, this is what HTML gives you. It gives you kind of descending heading sizes. You can't just keep going up though. If you do heading 7, I'm pretty sure it just doesn't work. Yeah, you can see my editor already doesn't like it. And yeah, it just displays normal text because it just falls back in normal text. It doesn't know what to do. So yeah, you only have 6. I've never actually used 6 headings in a project though, so I don't think that's a big limitation. All right, next we have lists. So you have 2 kinds. You have unordered lists and ordered lists. And you make an unordered list with UL and you make an ordered list with OL. So an unordered list is bullets. Whereas an ordered list is numbered. For each item that you have, you put it inside, you wrap that inside of an li tag for list item. So your whole list you wrap inside. So here's our start unordered list. Here's our end unordered list. And then here's all of our list items. And then same thing for ordered lists. So if we go ahead and run that, see what that looks like, you can see unordered list makes bullets, ordered list makes numbers. That's all there is to those. Not too complicated. You can also combine things. So like if you wanted to say like, maybe you wanted to make this strong, you can do that. So you can have tags within tags. That's one thing about HTML you always have to remember. You could also like link this to something if you wanted. So Maybe we want to link this. Right? You can do all of that stuff, and then it will give you a list item that is bolded and links to night hacks. So yeah, that's your ordered and unordered lists. We have code tags. You can wrap code inside of this. So, you know, say we wanted to have like a line of like say Python or something. We wanted to code just indicates that it should be code and it should be formatted differently. Usually in CSS, you handle how that actually looks. So maybe you want to say hello. And if you look, so by default, let me actually make this a little bit bigger because it's probably getting so small you can't really see what's happening anymore. By default, it kind of, you see how it prints in a different font than just the default one. It gives you a code like a monospace font instead. Of course, you can customize the way all of these things work in CSS, and most good sites do. So you may have actually seen sites that kind of look like this, and you're like, huh, why do there so many sites that have this kind of basic look? It's probably because they wrote it in just raw HTML with no CSS. But like a good modern site will use HTML and CSS to pick different fonts, customize the size of things, how they look. And but that's kind of what your default code tag will get you. And then your last two tags, you have div and span. So div and span are kind of different from the rest in that they have no semantic meaning. So they don't actually do anything. They're just by themselves. So if you just put things inside of it, it just looks like normal text. The idea behind these is that they're container tags. So a div stands for like division, and span, I don't know what span stands for, but it's another division. It's and they work slightly differently. But basically, the main reason you use it is to create a container. So in CSS, you often want to target, like say we want to target only this line with CSS. It would be difficult to do that by default because it's just regular text. Like it's not, because we don't want to style every single div in the same way, right? We might have two divs and we want one to look one way. Maybe we want this one to be red and we want this one to be green. So in order to do that, you can go to your CSS and you can create a CSS class. So the way you do a class is with a dot. And so let's say we want to make a red class. And then we want to make our color red and that. And then we want to make a green class. We want to make color green, do that. And then over here, you just have to put class equals whatever class you want to use without the dot. And then, so the div itself doesn't do anything, but it gives you a place to put this class so that you can say, okay, only the stuff inside of this division I want to be red. Only the stuff inside of this division do I want to be green. And then look, that's how you can target very specific parts of your HTML file without affecting anything else. Span works the same way. The main difference between those is span is inline, whereas div is a block element. And usually the only effect this has most of the time is with new lines. So if you have like a paragraph of text, like, okay, I don't know. And maybe we want, let's get rid of this span here. Maybe we want is to be red or maybe blue, right? Let's do a different color. So but we still want to like break lines or do anything like that. We still want it to be like embedded within this paragraph. So we can do this. And remember, the class itself doesn't actually do anything. You have to go to the CSS and associate that with something. So if we just run this, it probably will just do, oh, okay. So remember actually our original P here making everything red. So that's why it's showing up red. So this is having no effect currently. So if we want to add a blue class, we can do that. And then look, if you look, now that's the way you can kind of override the color. So now that's blue. But notice how it doesn't affect like the spacing or anything like that. Whereas if you do div, I believe what will happen is, let's just try and see. Yeah. So if you look at div will break lines. So it like automatically kind of does line breaking for you. Whether or not this is good, it just depends. But that's kind of your difference between div and span. So whenever you have something that breaks lines, it's called a block style element. So like an image is a block element by default, right? Because it's going to break lines. Div is a block element. Span is a inline because it doesn't affect, if you just use span, it doesn't affect the current spacing of how things are going. Also, actually, I think, hold on, let me go back a minute. I think we saw there's an error in the, yeah, so if you actually look here, when we use this div like this, because I think when we use this div inside of here, it actually breaks the parser, because if you look now, this is not red anymore. Probably because you're not supposed to put block size elements inside of a paragraph, because that doesn't make any sense. If you wanted to do another line break, you'd do a new paragraph. So that's, but if you look, okay, look, the whole page doesn't crash, right? So that's one thing that you have to understand about the web. When they wrote it, they assumed that the people who would be writing the code would be designers who had like no actual clue on how to write good code. So instead of having like warnings for things, like, when you try to run it, the kind of idea in web development in HTML, CSS, and JavaScript is just, no matter what happens, try to keep the train, even if the train like derails and goes off the tracks, just try to make sure it keeps running. Like, display something. It doesn't really matter if it's good or not. If it doesn't obey the rules, just no matter what, don't crash the page. Make sure something happens. Which you might think, oh, that's good. That's kind of like error fallback, but it can be bad, especially in JavaScript when you're trying to debug errors, that it just tries to keep running and just starts doing all kinds of terrible things you don't want it to do, instead of just giving you an error that would help you find the actual problem. But you just have to understand that's the context in which this was designed. They just wanted to make sure it kept running. So that's basically your whirlwind tour of HTML and CSS. CSS especially has like a lot more things than colors you can do. We're going to have a separate workshop on that, because that should be its own sort of thing. But you've basically learned most of the useful stuff in HTML. There are other elements like video and audio elements. But if you kind of understand the tag idea, where you have the open and close tag, and then also the idea that some tags don't have to be closed for whatever reason, and then you understand the properties, right? So you can have these properties, and you can also have multiple properties. So if you look at this link here, you have this rel that's style sheet, and href that's the path to your CSS. You can have multiple properties as well. You just put them next to each other like that. If you understand that, you basically understand the structure of HTML. Every web page is just built up of probably a lot more sophisticated, this kind of stuff, but that's what it looks like. And if you want to actually see this, like say you can actually view the source code of any given site. So if we go to Google and you kind of right click and go to view page source, you can see here is our page. Now, there's lots of other stuff going on in here, but you can see, look, there's our doc type HTML. Let me actually blow it up so you can. Here's our doc type HTML. Here's our HTML open and our laying on, and then head, meta. They've just put it all on one line to save space, because the fewer spaces they put, that's the less wasted space when they actually send the file over the network, because otherwise they'd have to send the space character. So they try to eliminate whenever they can, and you can kind of read the entire HTML page going all the way across here. Then you have all this other stuff. If you see this other like terrible code down here with function stuff, that is actually JavaScript. So most modern sites will not have very pretty HTML. And the reason is because ultimately HTML is just basic HTML is very limiting. You can do a lot with HTML and CSS, but once you reach a certain level of interactivity, like think about Google. As soon as you click this, look, I just clicked this box. It's already changed what the HTML of the page would look like, right? It's displayed this new thing. I type one character, it now needs to render in images in line. Trying to do this in pure HTML is just impossible. There's no way to like have that kind of interactivity. And this is like, for Google, this is a pretty simple page. Think about something like Google Docs, where there are like literally hundreds of buttons and different things that could happen, and keyboard shortcuts that could modify the page, right? You just can't do that with this kind of HTML and CSS model. So the way most modern web pages work to have that level of interactivity is by being mostly JavaScript. So basically what happens is you load a very, very basic HTML page with one div in it, and then you use JavaScript to dynamically render in HTML according to like programmatic. That way you can kind of program the page to interact with the user instead of just saying, here's the content I want. Because the content could be different, right? I type in night hacks. I see one thing. I can't spell, but you get the idea. I type in night hacks. You see one thing. I type in, something else. I see something else. So that's why most modern sites are not going to have very pretty source. All of this stuff is JavaScript that's doing the actual heavy lifting here. But if you look, we might actually be able to see the div. You can do this on any site, by the way. But yeah, you can see like, hold on. They set the title in here somewhere. They should anyway. Yep, so you see there's, they set the title to Google right here. And then they load in a script. And yeah, so here's the script open tag, and they start doing the script, which has been, they've run the script, no one is actually writing this horrible code, by the way. A computer automatically removes all the spaces and renames the variables to save characters of space to speed up the load time ever so slightly. That's why it looks so horrible like this. But if we go all the way past this, eventually we should find the end of the script. Yeah, here it is right here. So here's the end of that script tag, and then they load in a style, the CSS, which has also been heavily minified, which looks like it goes on for a while and ends here. And that's the end of the head. And then body, here's your body. They load another style, probably more JavaScript. So yeah, actually, if you look at the bottom bar here, you can see some of these lines are ridiculously long. But yeah, no one is actually writing this code. They're running it through another program to transform it like this to save space. So yeah, there you go. There's kind of a look at the internals of how Google works. Most modern interactive sites, Facebook, any like social media site, or even like a website like Walmart or something, like a shopping e-commerce website, is going to be, because you have that like click a thing and then everything changes, or type something and everything changes, that they're going to be like largely written in JavaScript with a JavaScript framework. And we are going to go over JavaScript frameworks in the future. But first we need to actually learn JavaScript. So before, it looks like we still have a decent amount of time today. So I'm going to go ahead and go to JavaScript, but first I'm going to take any questions on HTML or CSS that people have. Okay, so it looks like we just have one question right now. If you have another one, go ahead and post in the chat. How can you have a link open to a new tab instead of changing the current page? So I'm not sure if you can do that in straight HTML. Do you mean like making it so that when you just click the link normally, it opens in a new tab? Or like what I do is if you middle click, that will open in a new tab. So that's how I do it. But I think there is a way to probably force it. Okay, Dylan says, yeah. So if you put these specific properties in, so what he's saying is, so let's actually test this and see if he's right. That way, if he's wrong, we can publicly shame him. All right. So let's try this. So he's saying we should put the rel, he's saying that should go inside of our link tag here. So if we do rel equals no opener, no follow. Is there supposed to be a space? Okay, there's not supposed to be a space in between those. So no opener, no follow, target equals underscore blank. Yeah, so you might be thinking like, okay, who invented these names? And the answer is, here's another thing. There's a fair chance this is just like kind of a hack. Because a lot of things, a lot of things that people do in HTML and CSS are just hacks. Or in JavaScript, people use a lot of hacks in web development, which is not something I'm a big fan of. But That's how it is. The reason I don't like it is because it makes it tough for browser implementers. Again, because I just feel so bad for them. Because what happens is people use tricks like this with these like weird properties that like in a specific combination happen to do what you want. And then they start relying on that to happen. And then the people who make the browsers are like, okay, well, we can never change this ever because it will break for all the people who were like using it in the way they weren't supposed to. This might actually be the standard way to do this though. Despite how terrible it looks. Like if you think about this, is not a very good API. But let's reload and actually see. Yeah, okay, it works. There you go. So I just clicked it normally, new tab. So whoever read that question, that's how you do it, courtesy of Dylan. Okay, you can also, with JavaScript, you can fix a lot of your problems, which is some people like overuse it for that. Like anytime you can do something in pure HTML and CSS, do it that way. People used to do animations in JavaScript, and it's bad because you're running code in JavaScript, which is then being interpreted by the C++ in your browser. Whereas instead, you could have just had it directly interpreted by your browser by just writing the right CSS rules in. So if you can use pure CSS and HTML, you get better performance. Things are more likely to work correctly. Whereas if you do JavaScript, it's just going to be slower and worse. So anytime you can do something in HTML and CSS, you should try to do it there instead. Okay. Any other questions? Okay, yeah. So we have someone saying, I'm having trouble with the div tag. My text color isn't changing. Well, did you add the class? That's my first question. So remember, you need to add the class, and then you actually need to
You said
edit
dot
the
red,
CSS
dot blue when you
Huh?
made the class there? You said dot red, dot blue?
Yeah, so that's how it knows it's a class, because if you don't put that, it will look for, this is like, think like it would be like an element that is red. It would be something like this, right? Is what it's going to look for.
Yeah, I have that.
Okay, so if you have the dot, yeah, Amelia, make sure you save. That's a good idea. Yeah, I'll always save your files. Put the class, and you don't put the dot in here. Did you refresh to your browser page? That could be the other thing. If you do all of that stuff, it should work. If you're on any browser, it should work.
The text is coming up fine. It's just not changing color.
That's interesting. Well, what you can do, go to your own page and view source. So view page source and look and make sure that it's actually the same thing. So like make sure that this is showing up here. Another thing you can do to like look at a page. So these are your developer tools. We're kind of jumping ahead here, but inspect element. If you use, if I know people probably have seen inspect element from like that one kid at your elementary school or middle school who like modified the page to look like something completely different. Remember, they're not actually hacking the site because you're only changing what it looks like on the client. So Google's, if you're doing that, like, defacing Google's page, google.com on the server, the one that everyone else gets, still looks the same. All you're changing is what it looks like in your personal client, which can be fun, but ultimately it doesn't actually affect anything. So what you can do is check here. This is actually, and also you have to think about this, the browser implementer people also wrote this nice like highlighty tool where you can like hover over an element and it will show you the things that are inside that. And it's very impressive. I've always been super impressed by people who implement browsers. But check and make sure the code here is also what you inspect. If it looks like that and you're not able to get it working, DM me on Discord after this and we can try to debug exactly what it is. It's probably just a typo somewhere. So don't feel bad.
Span instead?
Huh?
Should I be using span instead of div?
Wait, are you using the div inside the paragraph? Is that what you're trying to do still?
Oh, mine's not inside a paragraph. That shouldn't
matter.
matter.
No, don't do that because that should break it, if anything, because it's not supposed to. Yeah, if you look what it actually does, it actually is translating it into this, and that's why this isn't getting highlighted, because you can't put a div inside of a paragraph. That's invalid HTML. But that I was just trying to show it will fall back and try to do like the next best thing. It will try to help you, which is a good thing usually. But
yeah, I got it.
You got it to work. Okay, great. Yeah, that's one annoying thing about like it doesn't always give you an error. Sometimes you just have to look carefully and look for a typo, because if you make a typo, it usually will just silently collapse, like it will try to do the right thing and then not warn you that it's not actually valid HTML, which can be bad. That's why it's important to get, if you don't have like a linter already, that will actually like read your code. So in your editor, you can get extensions for this. VS Code might have it built in, I don't know. But it will actually like check your code and like try to point out obvious errors, like you forgot a semicolon or you never closed this tag. That way it's less likely you'll run into mistakes. Like I was actually, for this exact page, I was trying to debug why my styles weren't working. And it was because I had style.css instead of styles.css. And like it didn't warn me. I had to like look through the console and try to figure it out. It's very annoying. Okay. We have a question. Where does the language like PHP come into play? I've heard people say for web development, you should know both JavaScript and PHP, but in general, why? Okay. So remember, PHP is actually like on the decline. If you like look up usage graphs of PHP, it's like it's going down. It's becoming less popular. Basically what PHP is it used to be the dominant server-side language. So your JavaScript would run on your front end like this, right? So that would do all your fancy buttons. And when you like type something, Google will render the little drop-down thing. PHP is actually what would be running on Google's server to actually like, because where is it getting those images from? They're stored somewhere on a Google computer. PHP is what's like taking the letter S, deciding what that letter S, what the best guesses are, and then giving you back those images. That's how you would use PHP. I would say PHP is not a terrible thing to learn, because one thing I'll say about programming is if you learn languages that are dying, you'll probably always have a job, because there will always be companies using these old technologies that have just refused to upgrade to the latest things. They don't want to like pay to do that. So they just continue to try to maintain their like 10-year-old code base or whatever. But PHP is on the decline. It's not really as popular. One of the main reasons is running everything on your server can get kind of slow. Big sites have, what people used to use PHP a lot for was actually dynamically rendering the HTML. So when you would go, instead of actually having an HTML file they would send you, like I believe if you probably have all used MyUCF, right? You know how it kind of renders into like a small box in the top left of your screen, and like when you click something, it has to load for like a second or two and grab it. I think it's using PHP or maybe like a similar language on the back end. That used to be the old way of doing things. So you would click a button, it would submit your information. It would do all the work on the back end to try to compute what the new HTML should look like, and then send you the new HTML. These days, the way usually they try to remove all of that processing from the server and move it back onto the client so that things are more responsive. So when you click it, immediately the page will start to change, and then you don't get sent what the new HTML should look like. It just sends you back the data, and the page itself in JavaScript will render what it should look like, which generally results in a better experience. But yeah, the short answer is PHP is one of many languages that can be used on the back end. It used to be very popular. It's still very popular, but it's become less popular. Okay, if there's no other questions, we still have about half an hour. So I'm going to start going over just some JavaScript concepts, because JavaScript is we'll probably spend most of the next workshop, maybe all of it, on JavaScript, because JavaScript is a massive, massive language. It started off as a very small prototype. It was originally written by Brendan Eich. He worked for Mozilla. He worked for Mozilla for a while. But basically, back when they had Netscape, probably, I don't think we were really alive when Netscape was, we might have been alive, but too young to remember, when Netscape Navigator was like one of the big browsers. But Netscape is like originally where you have JavaScript coming from. And they're trying to make it for like designers. They just wanted like a small little scripting language that could do some minor things to kind of enhance your HTML and CSS. They had no idea that someday like we would be putting our entire banking infrastructure and payments and everything on top of this language. It was just sort of supposed to be like a quick hack. The original prototype for JavaScript was actually written in 2 weeks. And some of the design decisions reflect that. So it's like, imagine trying to like finish your presentation like desperately before the deadline. It may not always be the best, right? JavaScript has some of that kind of in it. There are some things that are definitely bad. And I'll point those out as we go along. But the community, once we got a committee on it and they started to like make major changes for usability, a lot of things have massively improved to the point where JavaScript is a fantastic language. Like I can say that, yes, there are bad parts. There are still things that are missing that I wish it had. It's not always as clean as some other languages can be, especially like Python, right? That were designed from the ground up to try to be very clean and minimal. But you can do basically anything you want in JavaScript. And there are a lot of things it actually got right in its very first iteration that other people like Python still, in my opinion, do the wrong way. So with that, this is your very first JavaScript program. So if you open up script.js, so I'm still in this same folder here. If you fire up, I'm using Vim, but you can use whatever editor. Open up your script.js. You can see this one-line program I've written. We have console.log, hello world from JavaScript. Console.log is like print. So if you know like C, printf would be your analog here, or most languages have like a print. In JavaScript, it's console.log. This is probably one of those things that like he originally was like, okay, console.log, that sounds good. I can always change it, before the deadline. Just never got around to changing to print or something better. But this is how you print things in JavaScript. Oh, you have to go? Okay, that's awesome. Yeah, that's totally fine. If you need to go, by all means, go ahead. This is being recorded, and it will be posted on YouTube after this, so no worries. So this is how you do a print. Now, if you wonder, this has actually been on this this site the whole time. Where is this actually printing to? It doesn't print into your HTML. So there are ways to impact HTML from JavaScript. Like that's how these frameworks that we've seen, like that Google would use or someone like that would use, actually work. But by default, if you just do console.log, that's not going to print to your page. It actually prints into your developer tools. So if you go back to opening up your developer tools, if you go to your little drop-down menu, there should be like a web developer or a tools, and then you open your developer tools. There's usually a toggle shortcut too. In Chrome, I think it's Control-Shift-J. It's Control-Shift-I, Control-Shift-J, Control-Shift-K. Just try all of those. One of those will work in Chrome. In Firefox, it's Control-Shift-I. So when you do that, it will pull up your developer tools. It'll be like a little overlay here. Again, an amazing thing. This didn't used to exist, but the amazing browser people somehow found the time to write a whole set of tools that will help you debug your code for the web. If you head over to your console tab, this console is your JavaScript console. So you can see our thing got printed here. If we add like another code, let's say we want to do something else like print night hacks. Right, okay, so do that, reload our page. You can see that goes ahead and print here. Over here on the right, this can be useful sometimes for debugging. This will show you where the print was called. So script.js, and then this is line and column. So line 1, column 9, line 2, column 9. So yeah, that's just your basic log. Logging, usually your program, like you probably, if you haven't done web development before, you probably have never opened the developer console in your life. It can be kind of interesting sometimes to go on to like major sites and look at what's in their developer consoles. Because it's funny, like if you have a good site, you shouldn't be putting a lot of stuff to the console in your production build. But there are some sites that have like, you can see all kinds of debugging information being printed out, like your IDs and all kinds of crazy stuff happening in the console. So it can be fun to go and look there sometimes. But this is the main way you're going to be able to like debug and check your code from JavaScript, is this console. So that's how you do a print. That's pretty simple. JavaScript also has different variables. So actually, let me see. Is there anyone? And please don't be shy, because I want to make sure I'm catering this to the right section of people. Is there anyone here who hasn't programmed in any programming language before? And HTML and CSS don't count, because So some people will be like, a lot of people will look down on someone who's like, hey, I'm an HTML and CSS programmer, because they're not actually a programming language in the sense that a lot of other languages are, right? They just define how something looks. They're like markup languages. They're not really like a real programming language is what people would say. So if you've ever written in like a language like Python, C, Java, C Sharp, any of those kinds of things, C++, those sorts of languages, then that's fine. But if you've never written any of those, like, please put something in the chat or send me a private message on Zoom. That way I'll know to like cater this towards people who have never programmed before. If not, I'm just going to go ahead and assume you know at least the basics of programming. Some people will also look down on JavaScript developers. So there's kind of a long running trend in the industry of criticizing people who are JavaScript developers or front end developers in particular, because at least in the old days, right, you had the front end developers were usually like people who were the designers. Like they weren't like the real programmers. They're just working on the design of the page. All the real work was happening on the back end in PHP or Java or whatever. These days, front end frameworks are just as difficult as writing things on the back end. So there still is sort of some stigma around maybe being a front end developer, but don't let that get you if you encounter people who are like that. It's just as hard these days to write either. And a lot of times you really want to be a full stack developer and learn front end and back end. Okay, so no one seems to be saying they've never ever programmed in any language before. So I'm going to assume you know things like what a variable is, or like what is a string. So let's kind of start with some of those things. So if we want to make a variable in JavaScript, let me actually get rid of this console.log. We don't need it. If we want to make a variable in JavaScript, in the original versions of JavaScript, you could just make a variable like this, like Python. And people who come from Python often try to do this. And the sad part is it usually works. But you should never do this. And there are good reasons. If you do this, what it does is it creates a global variable that can be run or read from any script. And you might be thinking, okay, well, that's not a problem. Like I know what scripts are on my page, but a lot of times on like company websites, you might be running like ads, and your ad provider might have a script that they're running. If you have things that are in a variable like this, in a global variable, a random script from like an ad, for example, could read that variable, write information to it, and like compromise the security of your program. So you should never do this. Never write a variable like this, even though it will probably work. You shouldn't do it. And if you're coming from Python, you need to break the habit of writing your variables like this. So what we ended up having is we would have var. Var is how you used to. This is the old way of declaring a variable. So this gets rid of the global variable problem. Other scripts aren't going to be able to modify your thing. But it does have some other legacy issues and some unintuitive behavior that people don't like. So the committee decided to add 2 new keywords to kind of replace it, although you can still use var, you just never should: let and const. So in any code you write, you should always use either let or const. The only reason I bring up var and global variables is you might see very old JavaScript that still uses those. And like anywhere you see a var, it's probably safe to change it to let. But just know that var and let do mostly the same thing. They just have some weird edge cases. Let makes a variable that you can change. So if we just say, okay, let variable equals 5, then later we can change variable to something else. So maybe we want to make it 6 later. So if we run this, notice nothing will happen because we haven't printed. So let's run some console.logs. One thing you may notice is I'm not using any semicolons at the end of my line. This will work in JavaScript, usually. This is another kind of like bad thing about the language. You have this thing called automatic semicolon insertion that tries to guess where semicolons should go if you don't include them. And it usually works, but there are edge cases where it does highly, highly unintuitive things. So I recommend that you always use semicolons. Although technically, if you don't, most likely nothing bad will happen. It's another thing that's like, I feel like is a real miss. Like I wish it just actually you could not use semicolons and things would actually work normally all the time. But, you know, we don't always get what we want, especially with web development. So if we go ahead and run this, add our semicolons and run this, you'll see, okay, we print out 5, we print out 6. Another thing to note is if you're used to a typed language or like more strongly typed language like C, you might notice we're not declaring the type of our variable. So we're not doing like int or float, right? In JavaScript has dynamic typing. So the type of variable can actually change, which is, you should rarely ever do this, but you can. This will run perfectly fine. There's no reason why a variable has to only store numbers or only store strings. It's likely to be highly confusing to people if you do this, but it will work. Let's see. Someone's heading out. Okay, yes. The rest of this will be posted. So if you want to follow up and see the rest, you can. Thank you for coming. For the rest of you who are still staying, we're probably going to wrap in about 15 minutes here at 9:30. Usually, I'm going to try to keep it running till about 9:30. So here you have your variable. You can change it. It can even change to a different type. So you can change it to a string. And everything will still work fine. The other option you have is const. Const stands for constant. And what it usually means, you can't reassign the variable. So this line will just run fine. This will print out 5. But when we get here, we'll get an error because you can't, if you have something that's constant, you can't modify it to something else later. So you actually see that in our developer console down here. So you see the 5 printed out, and then we get this uncaught type error, invalid assignment to const variable. Yeah, so we have someone a question. The changes we make here do not affect the GUI. And if you don't know what a GUI is, like GUI, it stands for graphical user interface, right? So that's like this page is what she's talking about. Right. The changes we're doing here currently do not affect the GUI. JavaScript is deeply integrated with HTML and CSS. We can modify any kinds of, that's how your pages like Google and stuff work. We will get to that, probably not today though. I just want to try to show you the core language itself so you kind of understand, okay, how do you do things in JavaScript? And then I'll start showing you how do you interact with the actual page. I actually can show you one thing. If you want to debug in a different way, so you don't want to do the print, you can do alert. Alert will do a similar thing. You probably have seen this sort of thing before. Oh, but we still have our error with const. So let's change this back to let. If you do alert, it will create a little pop-up like this. You probably have seen something like this before, where it like pops up and it makes you say okay or whatever. You just click that, and then it will finish loading things in. So yeah, you can have alert. That's another way to do things. But usually console.log is the way to go. Yes, the million. If you ever run one of those like scam sites, it's like you're the 1 million winner or whatever, and you're not. Just letting you know. If that pops up, that's how they're doing it. It's literally just an alert. Not very hard to do. That's how that works. If you ever wondered. So yeah, you can do that. We can have constant. You might wonder, like, okay, why would I ever make anything constant? It just seems better to use let and make sure that I'll be able to change it if I want to. And like, fair point. But usually code that uses const is clearer, because I know if I use const, I know that anytime I reference variable later, it will still be 5. Like it can't change anything else. So for that reason, I'm an advocate of the constantly const ideology. If you can use const, if you don't intend to change the variable, or you're not sure if you should use const or let, just use const by default. And then if you later decide you need to use let, change it to let. Some people always use let and they just never use const. There are different approaches. That's something else you're going to learn with web development. There are different styles, especially within JavaScript. There are different ways to do the exact same thing and different stylistic choices. Some people always use semicolons. I generally say always use semicolons. But there are other people who say never use semicolons, and they specifically write their code like this. And different projects have different conventions. That's just how it is. Some people do things one way, some people do things a different way. What I would say is defer to whatever project you're working on the standards are. So the most important thing is to be consistent. So either do this or do this. Do not do this, and sometimes use it and sometimes not. Because being inconsistent, because then some people might think it's semicolon, some people might think it's not. You want to just make sure you stick to one. So if you find a project you want to contribute to, or you're working on a personal project, doesn't really matter too much what style you choose. Just pick one and do everything that way so it's consistent. Yes. Okay. So there's a comment you can use escape sequences in here. Yes. So if you want to do like, so if you're familiar with C, right, to do a new line, you would do /n. If we want to do the same thing in JavaScript, that also works. So you can see we get hello and then that new line in world. That is possible. Let's kind of discuss the different types that you do have. So a lot of people think JavaScript has no types. That's not true. You have types. You have numbers. You have strings. You just don't have to declare what they are on the variable. So we already seen numbers, strings. You have some other things you can use. Floats. So JavaScript doesn't really make a distinction between ints and floats. So if you want to float, you can just use a float, right? I mean, you don't have to. There's no type, so it's fine if you change it to a float. And if you want to add things that are floats and not floats, you can totally do that. All the math operators work the same as all the C-style languages. Most languages do this the same way. So all these things work the same way. It does follow order of operations. You do have mod, right? So this is completely valid JavaScript. You can do all of that. One of the most important types in JavaScript is the function. So you might know if you're in Intro to C, like I'm in Intro to C right now. So we're kind of like, we just sort of learned functions like last week, I think. In C, you might write something like this. Oh, and you'd also put types on these as well, right? So this would be like how you do a function definition. And then later, you'd be able to call that function by passing in your values. So you'd have this, and then what value would this return? This would return 5. By the way, this is comments in JavaScript. It works exactly the same as C. So if you want multi-line, you can do, you can do this. Do with the /* and then */ to end it. Or you can do the single lines with the //. Both of those work just like C. Yeah, so this is how you might declare a function in C. To declare a function in JavaScript, remember, we don't have types. So we get rid of all these ints. And then you just put function in front. And there you go. You've now declared a JavaScript function. It's not that complicated. All right, we have another person heading out. Yeah, awesome. This will be posted again, by all means. Head out if you need to. So this is how you declare a function in JavaScript. Let's go ahead and log this out just so that I can prove to you that it actually works. There you go, 5, right? 2 + 3 is 5, so this works. That's your functions. One thing to note, you don't have a main function. So you might be used to a style where you have a main function that gets automatically called. That doesn't really happen in JavaScript. If you want to think about the way it really works, the way it sort of works is everything is inside one grand main function. You can kind of think it automatically the browser will do this for you. You can think of it like that's how it works. If you used Python, then you'll be used to this sort of thing. If not, don't worry about it. Just know that you don't need to use a main function to start things off. This is one way to declare functions. You also have a camp of people who declare functions with const. And that is because in JavaScript, functions are a first class thing. So if you were I actually had a functional programming workshop where I kind of went into detail about this. But just like you can do let variable equal a number, or let variable equal a string, you can do the same thing. So we can do something like this, right? So const number equals 4. We can have a string that equals hello. We can also have a function, so our sum function, and we can write it the same way. So we can write a function like this. So in this case, the difference you'll see is instead of having the function at the beginning here, you have this const, and then you set it equal to with the function being on the right. And then you don't have to repeat the name over here. So it won't like be mad if you do this, but if you don't, it will still work. Everything else about it works the same way. So some people write functions like this. That's one style. Again, a stylistic thing, just try to keep it consistent throughout your project. I would never write it like this personally because it's just a lot more, it's more typing. You have to basically add an extra const because you still have to type function. So this is kind of silly. The reason this became popular is because of the arrow function. So an arrow function can just be specified with an arrow. It's the same components as in your normal function, but just boiled down. So this is how you might declare this with an arrow function. And you can kind of see the attraction for people at this point. So you do const and then the name of your function. And then you provide this is called a function literal, or some people call it an anonymous function, or a lambda. So those are the three names. It's confusing that there's three, but that's just the unfortunate reality. People call it function literal, right? Because it's just like a string literal or a number literal. It literally just means that function. A lambda, or an anonymous function because it doesn't have a name, right? We don't have to, it is named over here, but this function on the right side doesn't have a name. So that's what makes it anonymous. And the way you do it is you write in parentheses, you write your arguments just like you normally do. So just like in our sum here, our A and B, or our function here, A and B, you write that. Then you put an arrow. So my editor actually renders it into an arrow because I have a special font. But it's an equal sign and then greater than. And you just put them next to each other. So mine renders it into an arrow like that. But it still looks a lot like an arrow even if you don't have a font that changes it like that. So you put the arrow, and then you put the return value right after it. So note, you don't have to put return. It will just automatically return it. If you can also do if you have like multiple lines of code, you can also do the braces. If you do the braces, then you have to do return. So a mistake that happens a lot is like while you're changing code, you're like, I want to add, another line to this or whatever. And so you think I'm going to do this, and then you forget that this doesn't actually return anything. So if we call sum2 on this and then run it, oh, okay. It's mad that we have sum declared a couple of times. We'll delete that. You'll get this undefined back because the value of sum2 doesn't actually return anything. You have to actually put return if you do the braces. So this is another common style. You rarely see that one I deleted. You'll either see this one function or you'll see this const way. Again, it's a preference thing. Different projects do it different ways. So just follow the project standard or choose which one you personally like the most. Let's see, any other questions? Pointers or no? So sort of, the answer is no. You don't have to directly deal with pointers, but every programming language that is not a language that has pointers, so like not C or C++, any language that doesn't let you interact with pointers still uses pointers. It just automatically decides how to use them for you, if that makes sense. So we can get into the next time probably because we're running out of time today. Next time we can get into the details if you're curious exactly on how that works. But yeah, the answer is no, you don't have to explicitly ever use pointers, but some certain kinds of variables act like a pointer automatically for you. We have a question, how do you include comments? So just like C. So you can type a comment with // that'll give you a comment. Notice how it's kind of grayed out. You can also do the multi-line style if you want to do that. That's the other way you can do comments. And that doesn't have any impact on how the code runs. All right, with that, we only have about a minute left, and that's all the stuff I wanted to get through for today. Do we have any other questions about the JavaScript stuff I've shown you? Or if you have any questions about like, I know how to do this in another language, can you do this in JavaScript? I'm happy to answer that as well. Should we add semicolons at the end of functions? So you can. It's not going to cause problems. Usually you don't see it though, because no one ever like tries to write code. You shouldn't try to be like writing more code after this. If you do, I think it will technically work, but so I would say no, you're just wasting space. But if you like it, you know, you can do it. It doesn't necessarily, it will work. All right. I'm going to go ahead and cut it off there then. Doesn't look like we have any more questions. So thank you for coming. We'll have our next week. We'll have, I believe it's next week. Check the Discord. I'm not sure exactly when break starts, but next week we'll delve a lot more into JavaScript and cover like, you know, classes and a lot of the JavaScript specific features, and also how to like actually use it to do something other than print stuff into the console. So yeah, thank you for coming. Feel free to go ahead and take off now.